All right, so section 4.3 is introducing a new function called a logarithmic function, which we're going to see is the inverse of the exponential function. So first of all, what is a logarithmic function? This is the definition. Basically, a log function is defined to be if you take an exponential equation, you can rewrite it into this logarithmic form, and these are equivalent in every way. So a is the base of your exponential function, and then the base goes right here inside that little log, kind of as a subscript. And then if you have a to the y is equal to x, that means the log base a of x is equal to y. We kind of just remember that the exponent becomes the log. The log is equal. Log is equal to an exponent. Sorry, I can't even write. And remember, the base goes right there, okay? And this is read as log base a of x. Log base a of x. And just for, like a vocabulary, we're taking the log of x. It's just the base of my log is a. It's kind of like taking the cubed root of 4. What are you taking the cubed root of? I'm taking the cubed root of 4. What root am I taking? I'm taking the third root. This is taking the log base a, okay? So let's just practice rewriting these from exponential form to logarithmic form. This is going to be a log base. The base is 3. And then the exponent is 2, so it goes there. And I just always say, well, then the third number goes there. So this is a true exponential equation. 3 to the second power is 9. That means this must be a true log equation. The log base 3 of 9 is equal to 2. What does that mean? Well, the log base 3 of 9. What I'm asking you, when I ask you to do one of these, or not me, or whenever you're asked to do one of these, what we're saying is 3 to what power gives me a 9? I personally don't really think in terms of logarithms. I think in terms of exponentials. So 3 to the second power gives you 9. Okay? That's what a log is. This is log base 2 of 32 equals 5, because 2 to the 5th is equal to 32. Okay? That's how we convert these into logarithmic form. All right. Let's write these into exponential form. What's the base? 6. What's the exponent? 2. What does it equal? 36. This is true. 6 squared is 36. Therefore, this log must be true. Base, x. Exponent, z. What does it equal? Y. Log form, exponential form. Easy. Easy peasy. Evaluate. All right, so evaluating these are going to be, they're going to range from very hard, very difficult ones to relatively, again, it's not circling, to relatively easy ones. Start easy. So log base 5 of 25. So what I'm asking here is 5 to what power gives me a 25? Most of us are going to just do this one in our head. 5 to the second power is 25. Now, if you don't like thinking about it that way, you can just do this. Take log base 25, say it's equal to x, and I'm trying to find x. So let's write it in exponential form. 5 to the x is equal to 25. 5 to the x, let's see if we can match up our bases. 5 squared. Okay. The only way 5 to the x could be equal 5 squared is if x is equal to 2. Then we come back here and say, x is equal to 2. Now, I don't think you really need to do that on this one because it's pretty easy to just kind of do it in your head, if you will. Maybe just to verify on the calculator that it works. Let's see if the log base 5 of 25 is base 2 of 20. Let's see if, so we're going to go control, log. Let's see if the log base 5 of 25 is in fact equal to 2? Of course it is. So these are kind of tricky. Like on one hand, I want to try to do some in my head, but on the other hand, you guys might want to do some in your head, but maybe not do too many in your head or too much in your head. So for this one here, 7 to what power gives me 1/7? What power can I raise 7 to give me 1/7? What is the thing that moves that power to the bottom of the fraction? -1. Okay? What is the log base 4 of -2? Now we got some issues here. We got some problems. What is the log base 4 of -2? 4 to the x power gives me -2. Well, let's think about that exponential function y equals 4 to the x. Crosses at 1, kind of looks something like this, right? Logarithmic function, exponential function. So this thing is asking us, what can I input into this function? What x value can I put into this function and get an output of a -2? If I put in positive values, I get these nice big values. If I put in negative values, I get values closer and closer to 0. If I put in 0, I get 1. I can't even put in an x value to make this thing actually go to a y value of 0, much less a y value that is -2. Therefore, this is undefined. You cannot take the log of a negative argument. Okay? Same thing here. Exponential form. 7 to what power gives me 0? Now we're closer. We can get infinitely close to 0 with smaller and smaller x's, but even if x is -10,000, it's just going to be 0.000000001, right? So, undefined. In other words, we can't take the logs of negatives, nor can we take the logs of 0. And I think we're going to revisit that a little bit later, okay? But for now, let's just move on. All right, 3 to what power gives me a square root of 3? 3 to what power gives me a square root of 3? So, I don't know. I can do this in my head. Maybe you can, maybe you can't. If you like that, and you're good with that, then that's where you can just be done. If you're not seeing it or you're not sure, let's work it the alternative way. Set it equal to x. I need to find x. Let's write it as an exponential. 3 to the x power gives me the square root of 3. So this is 3 to a power. Let's write this as 3 to some power. The square root of 3 is equivalent to 3 to the 1/2 power. The only way 3 to x can be equal to 3 to the 1/2 is if x is equal to 1/2. Therefore, that's the value. You should be able to kind of see that in your head. 3 to the 1/2 gives me the square root of 3. Okay, this one here, we have a decimal. Now you might say you hate fractions. All well and good. You can hate fractions if you want, but decimals are even worse to work with. So this is the log base 2 of 0.025. That is 1/4. All right, so now this is one that's kind of a little bit harder to do in your head because it's kind of a two-step problem. First, what power is going to take that 2 and move it down to the bottom of the fraction? By the way, that's going to be a -1. And then what value is going to take that 2 and make it a 4? -2. Again, don't do it in your head if you don't like to do it in your head. You can set it up. 2 to the x power equals 1/4. I need to match up my bases. 2 to the x, 1 over, let's write this 4 as 2 squared. How do I move that power up to the numerator? You simply make the exponent negative. 2 to the x is equal to 2 to the -2, therefore x is -2. Therefore, the log base 2 of 0.25 is -2. All right, a couple more. These ones are, now this is my attempt to kind of give you ones that, even if you're kind of pretty good at doing these in your head, these ones are going to be kind of tough. In fact, in class, I kind of challenge people to do this. So 2 to what power gives me the 5th root of 4 divided by 8? And you can kind of, well, I don't know. I think when you get good at them, you can kind of do these in your head, but let's not. I would encourage you not to do this on a test, right? So let's just say this is equal to x. You don't need to write that. Let's just write this in exponential form. 2 to what power gives me the 5th root of 4 over 8? So what base can I get 2, 4, and 8 to so that they're all the same? Base 2. So this one I'm going to leave alone. 4 I'm going to write as 2 squared. And 8 I'm going to write as 2 to the 3rd. Okay? 2 to the x equals. Now, if you have the 5th root of 2 squared, remember, the 2 becomes your numerator of your fraction, and the 5 becomes your denominator. Now we need to review our rules of exponents. If we have the same base and we're dividing two powers with the same base, you subtract their exponents. So what is 2/5 minus 3 over 1? What is 2/5 minus 15/5? Sounds to me like that would be negative 13/5. Therefore, the only way 2 to the x can be equal to 2 to the negative 13/5 is for this to be equal to negative 13/5. Now that'd be pretty tough to do in your head. Okay? So if you're just watching this video, I'd encourage you to pause it, maybe give this one a go, try it. Or if you're lazy and you just want me to do it, I will do it here in a second. Let me just try to, should have left more space in the notes. I apologize for that. Because I could have paused the video while I erased. All right, let's do this one. I'm going to say this is equal to x. So 3 to what power gives me the square root of 3 over 27 times the cube root of 9. What base can I get all of those to? Base 3. 3 to the x, done. 3 to the 1/2, done. 3 to the 3rd. And we want to do this in 2 steps. 9 is going to be 3 squared. And then I'm taking the cubed root of 3 squared. I'm going to do it in 1 step. That's 3 to the 2/3 power. So 3 to the x equals 3 to the 1/2 minus 3 over 1 minus 2 over 3. I take the top, subtract the 2 power exponents from the bottom. So what is 1/2 minus 3 over 1 minus 2 over 3? Let's get these all to a 6. Common denominator. So that's 3 minus 18 minus 4 all over 6. That would be 3 to the negative 22 plus 3 is negative 19/6. So x is equal to negative 19/6. We got 1 minute before the video is over. I wonder if the calculator can do this. Let's see. They can do it in exact form. Sometimes the calculators can do, a lot of times the calculators can do this kind of stuff, but sometimes it kind of, the algorithms don't quite work right? So this is a square root of 3, 27 times the 3rd root of 9. I don't know. What do you guys think? I don't think it's going to do it. See there? It doesn't do it. It should. It should see that this 3 to what power gives me an 81. But it can't do it. For some reason. Who knows why. If we hit the last control enter, negative 3.1, I bet you that's negative 19. Was it 6? Yeah. We can do more than the calculator. Boom.